Amazon Managed Streaming for Apache Kafka, MSK. Introduction to Amazon MSK. 1. Managed AWS Service. Amazon MSK stands for Amazon Managed Streaming for Apache Kafka, making it easier for developers and DevOps managers to run Apache Kafka applications on AWS. 2. Focus on Apache Kafka. The service takes care of the Apache Kafka infrastructure, including its operation, maintenance, and scaling. 3. AWS integrations. It offers built-in AWS integrations that help to speed up the development of streaming data applications. 4. Enterprise-grade security. Security features are provided out of the box. 5. Cost-efficient. There are no data transfer charges for in-cluster traffic, and you only pay for the resources you use. What is Apache Kafka? 1. Open source platform. Apache Kafka is an open source platform, making it accessible for developers to use and modify. 2. High performance. It is designed to handle high-speed data transfer and operations efficiently. 3. Fault tolerant. Apache Kafka is built to be resilient, ensuring that data is not lost during system failures. 4. Scalable. The platform can be easily scaled up to meet growing data needs. 5. Producers and consumers. Apache Kafka decouples data-producing applications, producers, from data-consuming applications, consumers. 6. Real-time analysis. Organizations use Apache Kafka for applications that continuously analyze and react to streaming data. 1. Amazon MSK makes it convenient for users to run Apache Kafka on AWS. 2. Apache Kafka cluster creation. Users can create their Apache Kafka cluster on AWS, leveraging robust infrastructure. 3. Client applications integration. With AWS, users can build or configure their Apache Kafka producers and consumers using services such as Amazon EC2, AWS Lambda, and Amazon Kinesis Data Analytics. 4. Producer and consumer connections. It's essential to connect both producers and consumers to the Amazon MSK for data streaming and processing. 5. Running streaming applications. Once everything is set up, users can run their streaming applications on the platform efficiently. Introduction to streaming data. 1. Definition of streaming data. Streaming data can be understood as a continuous flow of small records or events generated from various sources such as machines, devices, and applications. 2. Record or event size. Typically, a record or event in the context of streaming data is just a few kilobytes. 3. Variety of streaming data. Streaming data can come from numerous sources like log files from web applications, in-game activities, social networks info, trading floors data, and more. 4. Example streaming data services. Services like Amazon MSK and Amazon Kinesis data streams are specifically designed to facilitate the collection, processing, and delivery of this kind of data. How Amazon MSK works. 1. Per cluster VPC. This virtual private cloud, VPC, encompasses the main Kafka components such as brokers and zookeepers. 2. MSK, managed streaming for Kafka, VPC, your personalized VPC where individual Kafka components reside in subnets. 3. Zookeepers, A, B, C, these are crucial components responsible for managing the Kafka brokers. There are 3 zookeepers in this architecture for fault tolerance. 4. Brokers, A, B, C, Kafka.m5.4xl. Kafka brokers manage the storage, reception, and transmission of messages. Their instance type here is Kafka.m5.4xl. 5. Subnets, A, B, C, within your MSK VPC, Kafka components are distributed across 3 subnets for redundancy and high availability. 6. Availability zones, A, B, C, each subnet and its associated Kafka components reside in separate availability zones, ensuring resilience against zone-specific failures. 7. Producer and consumer. Producers send messages to brokers, and consumers read messages from brokers. They are typically client applications. 8. Cluster operation. Represents tasks and operations that can be performed on the cluster, such as scaling, monitoring, and managing. Key concepts of Apache Kafka. 1. Topics and records. Apache Kafka stores data in topics. Each topic can have multiple records. 2. Producers and consumers. Data producers write records to topics, and consumers read from them. 3. Record components. A record consists of a key, a value, a timestamp, and possibly header metadata. 4. Partitions and replication. topics in Kafka are partitioned and replicated across nodes. 5. Brokers, Kafka operates on multiple nodes known as brokers. 6. Highly available cluster, brokers can be located in multiple AWS availability zones, ensuring high availability. 7. Role of Apache Zookeeper, Kafka relies on Apache Zookeeper for cluster coordination and state maintenance for resources. Introduction to MSK Serverless. 1. What is MSK Serverless? MSK Serverless is a cluster type for Amazon MSK that enables Apache Kafka clusters to run without compute and storage management. 2. Run applications without cluster management. MSK Serverless eliminates the need for provisioning, configuring, or optimizing clusters. 3. Pay per data volume model. The cost structure for MSK Serverless is based on the volume of data you stream and retain. MSK Serverless, Partition Management. 1. Automatic partition balancing. MSK Serverless automatically balances partitions within a cluster. 2. Fully managed partitions. The service takes care of monitoring and moving partitions to even the load across a cluster. MSK Serverless, Data Throughput Capacity. 1. Write capacity, 200 megabytes per second. MSK Serverless supports up to 200 megabytes per second of write capacity per cluster. 2. Read capacity, 400 megabytes per second. It provides up to 400 megabytes per second of read capacity per cluster. 3. Instant write, 5 megabytes per second per partition. There is up to 5 megabytes per second of instant write capacity allocated for each partition. 4. Instant read, 10 megabytes per second per partition. Up to 10 megabytes per second of instant read capacity is allocated for each partition. Introduction to MSK Connect. 1. Feature of Amazon MSK. MSK Connect is a specific feature integrated into Amazon's managed streaming for Kafka. 2. Uses Kafka Connect 2.7.1. The feature is built on the Kafka Connect 2.7.1 framework for seamless data streaming. 3. Fully managed connectors. It allows you to deploy connectors that are fully managed, eliminating the need for manual management. Functionalities of MSK Connect. 1. Data ingestion. You can use source connectors to pull data into your Kafka topics. 2. Data export. Sync connectors allow exporting data from your topics to external systems. 3. Third-party connectors. It supports connectors developed by third parties, such as Debezium for streaming database change logs. Versatility and monitoring in MSK Connect. 1. Supports any Apache Kafka cluster. MSK Connect is versatile, supporting any Apache Kafka cluster that can connect to an Amazon VPC. 2. Autoscaling. The feature can automatically scale connectors to match changes in throughput. 3. Health and delivery monitoring. MSK Connect constantly checks the health and delivery state of connectors, providing seamless operation. Connectors in Apache Kafka. 1. Definition. A connector integrates various external systems and Amazon services with Apache Kafka. They function by continuously copying streaming data either from a data source into the Apache Kafka cluster or from the cluster to a data sink. 2. Data source and sink. Source connectors pull data from a source, pushing it into the cluster. In contrast, sink connectors extract data from the cluster, directing it into a data sink. 3. Logic and transformation. Connectors can perform lightweight operations such as transforming the data, converting its format, or filtering it before it reaches its destination. The following diagram shows the architecture of a connector. A worker is a Java Virtual Machine, JVM, process that runs the connector logic. Each worker creates a set of tasks that run in parallel threads and do the work of copying the data. Tasks don't store state, and can therefore be started, stopped, or restarted at any time in order to provide a resilient and scalable data pipeline. Connector Capacity Overview. 1. Definition of MCU. MCU stands for MSK Connect Units. Each MCU represents 1 CPU of compute and 4 GB of memory. 2. Worker memory versus heap memory. The mentioned MCU memory pertains to the total memory of a worker instance, which is different from the heap memory that is in use. 3. 2 capacity modes. There are 2 modes to choose from when creating a connector, provisioned and auto-scaled. 4. Purpose. This mode is ideal for those who are aware of their connector's capacity requirements. 5. Values to specify. In this mode, 2 main values are specified, the number of workers and the number of MCUs per worker. 6. Purpose. This mode is preferred when the capacity requirements for your connector are unpredictable or if you're unsure about them. 7. Amazon MSK Connect's role. With autoscaled mode, Amazon MSK Connect will override your connector's tasks.max property. This new value will be in proportion to the number of workers in the connector and the number of MCUs per worker. Workers in Kafka Connect. 1. Workers defined. A worker is a JVM process that runs the connector logic in a data pipeline. 2. Role in data pipeline. Workers create tasks that operate in parallel threads, facilitating the data copy operation. 3. Task characteristics. Tasks operate without storing state, allowing them to be started, stopped, or restarted at any time. 4. Worker coordination. Changes in the number of workers are detected by the remaining ones, leading to automatic task rebalancing. 5. Variable capacity. MSK Connect can autoscale the number of workers between a lower and an upper limit. 6. Fixed number of workers. You can specify the exact number of workers to run your connector logic. What is Apache Zookeeper? 1. Centralized service. Apache Zookeeper serves as a centralized service in a distributed system. 2. Configuration information. It maintains configuration data that's crucial for the distributed applications. 3. Distributed synchronization. Zookeeper helps in achieving distributed synchronization across nodes. 4. Group services. It provides group services to manage distributed applications effectively. 5. Used in distributed applications. It's essential for the functioning of various distributed applications. 6. Including Apache Kafka. Apache Kafka is one of the many distributed applications that utilize Zookeeper. Amazon MSK and Apache Zookeeper. 1. Amazon MSK uses Zookeeper. Amazon MSK incorporates Apache Zookeeper for its service. 2. Managed within each cluster. Zookeeper is managed within each Amazon MSK cluster. 3. Nodes included. Apache Zookeeper nodes come included with each MSK cluster. 4. No additional cost. These Zookeeper nodes are part of the MSK service and incur no extra cost. How data replication works in Amazon MSK. 1. Leader-follower replication. Amazon MSK uses Apache Kafka's leader-follower replication model to replicate data between brokers. 2. Multi-OS clusters. MSK simplifies deployment with clusters spanning multiple availability zones, OS. 3. Custom strategy by topic. You have the option to define a custom replication strategy at the topic level. 4. Leader and follower brokers. Both leader and follower brokers get deployed and isolated based on the chosen replication strategy. 5. 3-OS broker example. For instance, with a 3-OS broker replication strategy and 1 broker per OS, a cluster of 3 brokers will be created. 6. Topic replication factor. By default, the topic replication factor matches the number of brokers in the cluster, unless manually overridden. Kafka APIs. In addition to command line tooling for management and administration tasks, Kafka has 5 core APIs for Java and Scala. 1. The admin API to manage and inspect topics, brokers, and other Kafka objects. 2. The producer API to publish, write, a stream of events to one or more Kafka topics. 3. The consumer API to subscribe to, read, one or more topics and to process the stream of events produced to them. 4. The Kafka Streams API to implement stream processing applications and microservices. It provides higher-level functions to process event streams, including transformations, stateful operations like aggregations and joins, windowing, processing based on event time, and more. Input is read from one or more topics in order to generate output to one or more topics, effectively transforming the input streams to output streams. 5. The Kafka Connect API to build and run reusable data import/export connectors that consume, read, or produce, write, streams of events from and to external systems and applications so they can integrate with Kafka. For example, a connector to a relational database like PostgreSQL might capture every change to a set of tables. However, in practice, you typically don't need to implement your own connectors because the Kafka community already provides hundreds of ready-to-use connectors. Amazon MSK integration. 1. Amazon S3 via Kinesis Data Firehose enables easy, no-code data delivery to Amazon S3 from MSK. 2. Amazon VPC provides network isolation and security for MSK. 3. Amazon CloudWatch, used for metrics monitoring. 4. AWS KMS enables storage volume encryption. 5. Amazon IAM manages authentication and authorization for Apache Kafka and service APIs. 6. AWS Lambda, used for MSK event sourcing. 7. AWS IoT, utilized for IoT event sourcing. 8. AWS Glue Schema Registry, controls schema evolution for Apache Kafka applications. 9. AWS CloudTrail, keeps track of AWS API logs. 10. AWS Certificate Manager, manages private CAs for client TLS authentication. 11. AWS CloudFormation, describes and provisions MSK clusters via code. 12. Managed Service for Apache Flink, manages Apache Flink applications that process streaming data. 13. Apache Flink Studio, allows interactive streaming SQL on Apache Kafka. 14. AWS Secrets Manager, stores client credentials for SASL/SCRAM authentication. Thanks for watching.